All right, next up is a bit of a weird one, ion dipole forces. The other intermolecular forces were between molecules that are the same, like two water molecules. Here we're comparing something that's between an ion and a dipole, hence the name. So sometimes it's not considered to be kind of one of the three main intermolecular forces, right? It's a fourth one. Some people do. It kind of depends on who you ask. This ion dipole force explains why salts. So remember, salts are positive, negatively charged ions dissolve in polar solvents. So earlier in the semester, right, we said like dissolves like, and the reason that like dissolves like in terms of salts dissolving into polar solvents, but not non-polar solvents, is because of this ion dipole force. So, for example, if you have a sodium ion and if you dissolve it into some kind of polar compound, it has a positive charge. It's going to be surrounded by the negative end of our dipoles. And the same or the opposite for the anions, something like the chloride ion, it's going to be surrounded by the partial positive ends of your polar compound. Of course, the most popular polar compound for us is water. All over the place, most of our Earth, most of us, it has the dipole end. The positive are towards the hydrogen, and then the oxygens are, or the negative is obviously towards the electronegative oxygens.